Now that we have looked at the production possibilities frontier and gotten to understand that we can see the opportunity cost from the slope of the production possibilities frontier, we can use that information to actually quantify or solve for the opportunity cost that each person or each country is facing. So we have here Marianne and Gilligan. When this model was first created, it was showing the improvement you would face if you did trading. And so the old story was the castaway on the island. Robinson Crusoe had his production possibilities frontier, and he was able to produce everything he needed, but he was limited by what he could produce. And then when Friday shows up, and Friday can do some production, and Robinson can do some of the other, and then they specialize in what they're best at. That's the key part. And then they trade for what they did not otherwise produce for themselves. And so the whole point of all of this was to show that everybody is improved when there's trading, that you can actually improve yourself through trade, be at a place that is otherwise outside your PPF and therefore something you can't get to on your own. You can actually consume beyond your PPF if you will trade. And the magic is that you need to specialize in the good that you are able to do relatively or comparatively better than the other person. And by doing so, you would specialize in the very simplified model that we look at. You specialize completely in that good. You don't make any of the other. And the other guy does the other thing. And then you trade. And you'll end up better off. And so that's really the point of this example. And so we're going to update it a little bit to Gilligan's Island. We've got Marianne and Gilligan needing to produce fish and pineapples. We got Marianne with the PPF we saw before, where she can do 10 fish in a day or 20 pineapples. And we've got Gilligan only able to do 5 of each. So there's 2 concepts we want to know. One is absolute advantage and one is comparative advantage. Absolute advantage is who can produce the most of something. So looking there at those graphs, we see Marianne can do 10 fish in the same time period it takes Gilligan to get 5. So 10 being bigger than 5 means she can outproduce them. Marianne has the absolute advantage in fish. We look at pineapples. We see she can do 20 pineapples and poor Gilligan can only do 5. So again, she can outproduce them. And so this is the sort of situation that this lesson was supposed to enlighten us about. Was even in this situation where you have Marianne outproducing Gilligan in everything, or a country outproducing a smaller country in everything, even in this situation, there is actually room to benefit from trade. And it's because Marianne faces different opportunity costs in producing fish and pineapples, especially compared to Gilligan. See, that's that comparative advantage. And so trade is decided on comparative advantage. All right? Just go ahead and get that one in your head. Trade is decided on comparative advantage. Absolute advantage is interesting. You can have a situation here where somebody can outproduce the other guy completely. You can have one have the absolute advantage in one and one has absolute advantage in the other. That's all interesting and informative information that could certainly show up on a test or quiz. But it does not determine which product you should produce. The thing that determines what you should produce and thus trade for is comparative advantage. So we want to talk more about comparative advantage and how you find who has comparative advantage in each product. All right. So let's see here. We've got Marianne who can do 10 fish and 0 pineapples. That's one extreme possibility. Or she can do 20 pineapples and 0 fish. And so because, like we talked about before, this is a straight line PPF, this is a constant marginal opportunity cost, her trade-off between how many fish she has to give up to get another pineapple is constant. She's moving down along the PPF. The slope of the PPF is constant, so she has to give up the same amount of fish for every pineapple. So for that reason, we can mathematically do something kind of simple here, where we can just look at her 2 extreme situations of 10 fish or 20 pineapples. And since both of these are possible outcomes, we can just say these are 2 equal outcomes for her, that she could have either the 10 fish or the 20 pineapples. And if you do this, this allows you to solve very easily for the opportunity cost of a fish or the opportunity cost of a pineapple. So let's go ahead and just solve for an opportunity cost of a fish. So what you want to know is how many pineapples do you have to give up for one fish? Right now we've got 10 fish is 20 pineapples. So divide both sides by 10, and 1 fish will be equal to 2 pineapples, because 20 divided by 10 is 2. And so what this means then, if we want to put this into English, is 1 fish costs, or has an opportunity cost, of 2 pineapples for Marianne. That is, the opportunity cost of 1 fish is not producing 2 pineapples. All right, let me say that again. The opportunity cost of producing 1 fish is not producing 2 pineapples. Every time Marianne produces a fish, she's not producing 2 pineapples, she's giving up 2 pineapples. So a fish, in that sense, costs Marianne 2 pineapples. All right, what about Gilligan? Let's see here. For him, it is 5 fish is one possible extreme, and 0 pineapples, or you can do 5 pineapples and 0 fish. So we can see very clearly then that his trade-off is pretty straightforward. 1 fish equals 1 pineapple. Every time he decides to catch a fish, he's not producing a pineapple. All right, so just looking at these two right here, who has the lower opportunity cost in producing fish? Marianne, 1 fish cost her 2 pineapples. Gilligan, 1 fish cost her 1 pineapple. Since let's see, how should I do this? 2 pineapples is greater than 1 pineapple. The cost is for Marianne is 2 pineapples. The cost for Gilligan is 1. That means Gilligan has the comparative advantage in pineapples. Did I say it right? In fish, sorry. Gilligan has the comparative advantage in fish because he gives up fewer pineapples when he gets a fish. It costs him 1, it costs her 2. So with comparative advantage, it's always going to be the case you can only have the comparative advantage in one thing. So if he is comparatively better at fishing, then she will be comparatively better at pineapples. You cannot, here's another one you can put in your brain, you cannot have the comparative advantage in both products. But to go ahead and prove that to us, let's go ahead and calculate the opportunity cost of pineapples for her and for him. So again, starting off with a 10 fish equals 20 pineapple. We now want to know what is the opportunity cost of 1 pineapple for her. So we divide both sides by 20, and that leaves 1/2 a fish. So every time Mary Ann does spend her time getting a pineapple, she's giving up the ability to catch half a fish. Looking again at him, you could just look back up top, but just to go ahead and be complete, he's going to have this 1-to-1 trade-off again. So 1 pineapple is the same, is him not getting 1 fish. So if we want to compare the two, we now have the cost of a pineapple for her as 1/2 a fish, which is less than the cost to him of a pineapple, which is giving up 1 fish. So she has the comparative advantage in fish. He has the comparative, excuse me, I keep saying that wrong. He has the comparative advantage in fish because it cost him 1 pineapple, not 2. She has the comparative advantage in pineapples because she gives up half a fish and he gives up 1 fish. So this is a good technique for finding out who has the comparative advantage, and then you know that the person will specialize in the thing they have the comparative advantage in. So what will happen, this goes on a little beyond what we need to do, but what will happen, just so you understand the importance of this conclusion, is if she is going to do pineapples, she will actually produce, at this point here where I'm drawing on the graph, 20 pineapples. He will spend all his time fishing and will produce up here. And then they will trade for the others. And so what will happen is they will end up on some point out in this area, which is beyond their PPF. How they bargain, what the price is of fish to pineapple, that's going to be up to their bargaining power. She would be willing, let's see, if she's doing pineapples. So as long as she's getting paid more than half a fish, it's a good deal for her. And as long as he's not paying more than 1 fish, it's a good deal for him. If the prices are outside those ranges, they're better off doing it themselves. So what that means is there's room for negotiations for fish and pineapple prices. And so what will happen then in this example would be looking at her graph, if she's producing here at the pineapple quantity, she is now facing essentially his trade-off. She does 20 pineapples and then hit the production from that point of fish is his 1 fish equals 1 pineapple. And so you would actually have his ppf come off of that spot. And if you don't get this, that's fine. I'm just telling you where this would go. And then for him, we're now facing her production. He's doing the 5 fish and she's producing the pineapples. And so you'd be off her ppf. And then you would see that regardless of where they actually negotiate, they're going to be at a point that's beyond their ppf. And this meant that, this was groundbreaking back in the 200, 300 years ago when they came out with this, was that trade is good for everybody. Previously, it was a more mercantilist view that it's only good maybe for the stronger, or that by trading you may be losing something. It was all fear that you needed to make sure you got the best of the deal. But what this showed is that everybody is improved if they specialize in the thing that they have the lowest opportunity cost, the thing they have the comparative advantage in, and then trade for the other good.